Hi, my name is Doug Summerlin, and in this video, I will show you how I made a smart doorbell that can detect and document someone's presence using only a Raspberry Pi with a camera module and a little bit of Python code. I hope you enjoy, and let's get to it. The setup for this project was nothing fancy. I just secured the Raspberry Pi with the camera module in place while the camera was pointed at my front door. It is important that the camera module doesn't move much, so I made sure the rig was secure using tape. I made sure the Pi was supplied with a reliable power source, such as a USB-C wall plug adapter.
This is the first of two programs I used to complete this project. The goal of this program was to define the detection zone by creating a mask of the image taken by the Pi. To define this zone, I used the select ROI function to select XY points on the original image from the Pi to represent the bounds of my trigger zone. After clicking a point on the image with the cursor, the function will print an XY coordinate of that point to the terminal. I used 10 points of interest total to define my trigger area. To create the mask, I defined an array of zeros to make a black mask the size of the entire image. Then I made an array of points using the XY coordinates I got from the select ROI function. The fill convex poly function from OpenCV will then fill in the polygons created from the defined points with a value of 255 to assign a high value to the area of the shape within the polygon. The bitwise AND function will be performed to return the original image wherever the image is high, which will be inside the area of the polygons. The remainder of the image will be completely black. This mask is performed so that we only have to examine the relevant area where someone would walk up to the door and ignore noise from the other parts of the image. Now the masked image is ready for further processing in the next program.
Here I will run the program using the array of points I found from the select ROI bounding box. It returns this masked area, which will be the detection trigger zone, and you can see the difference between the original image from the Pi and the newly masked image that eliminates all of the image that will not need processed by my second program.
This program, titled Smart Doorbell Masking 02, is the main program of my smart doorbell apparatus. After the command has been executed, it will run continuously as long as the Pi has power. The script is quite lengthy due to the many functions of the program, so I will just outline the main detection algorithm and some of the other functionality in the code. I began by importing all of the relevant libraries and including the defined mask from the first program. Once the mask image is taken, the image is blurred, resized, and put into grayscale. This will make it easier to compare to another image, speeding up the code. I then began the main loop and added a counter to track how many times the loop had been executed. Now we encounter the main detection algorithm. The idea behind the entire program is taking two images from the Pi camera, processing them for speed and accuracy, and determining if they are different enough from one another to imply that someone or something is in one image that's not in the other. This will trigger a detection. To measure the difference between the two images, each pixel in the processed image will be compared. To set a measure of difference, a pixel threshold of 50 out of a possible 255 in grayscale is defined, such that if two pixels in the same location differ in gray value by 50 or more, that difference will be considered sufficient. I then compared the pixels of the two images one by one, row by row, and column by column. If the absolute value of the difference between two pixels was more than the defined threshold value of 50, that pixel of the detector array, which is also the size of the image, will be given a high value of 255. Upon completion of the pixel comparison, the detector array is summed to determine a total level of detection, and if this value is above 20,000, it triggered a detection in my program. This value can be adjusted for better performance, but 20,000 worked just fine for me. Upon the detection by the program, an alert will be printed to the terminal, and the Pi will take a 15-second recording of the front door area to attempt to capture the disturbance. The recording is converted to MP4 and uploaded to my Dropbox account. The next sequence of code takes the original, masked, and processed image from the trigger moment and sends them from a user-defined email to another user-defined email. This last block of code uses the online service Twilio to send an instant text alert from a Twilio phone number to a user-defined number to get immediate notification of a possible guest or delivery. And if the detector threshold is not triggered, the terminal prints that nothing has happened, and the code will loop again until a detection is eventually triggered.
Here I am recording the terminal on the Pi using a headless setup on my laptop to test the functionality of my code. The Pi is located in this window and is pointed at the front door, where hopefully it will detect me successfully as I begin my approach. Because nothing is at the door, the program prints nothing detected yet, but as I enter the triggered detection zone, you can see the detector total surpasses its threshold, and the program then prints an alert that someone is at the door. As the program continues its detection algorithm, it provides updates on the status of the video recording as it converts it from an H.264 file to an MP4 file and uploads that recording to the Dropbox cloud, where I can view it later. As anticipated, upon examining my Dropbox account, I find a video of a ridiculous-looking man holding both a laptop and a phone. This means that the Pi successfully noticed a phenomenon that exceeded the trigger threshold, took a 15-second recording, and uploaded it to my cloud. As you can see from this session of testing, the Smart Doorbell has sent me lots of emails from my alternate account after many successful trials of the system, which with a little bit of threshold tweaking also works at night with sufficient lighting. The program sends the captured images to my personal email account from my alternate account, and it includes the 2 successive trigger images, the grayed, blurred, and resized images, as well as the mask images. To implement the text notification feature, I set up a Twilio account and use the account information to send a text to my personal phone using the Twilio client library on Python to instantly alert me of a possible guest.
So here I'm actually using my little brother's phone to videotape my phone screen, and here we see that the Twilio app has been sending me a text message which is consistent with my code for every successful trial run of the Smart Doorbell system with the Raspberry Pi.
I hope you enjoyed watching this video as much as I enjoyed making this project. A big thanks goes to Dr. Mitchell at the University of Maryland, whose instruction made this video possible. Go Terps!